Hello, this is Engineer Abdeen and we are back to you again with another tutorial on relays and sequencing. In today's tutorial, we have a different sequence. We have A plus, B plus, B minus, A minus. So again, to approach this problem, we follow the same exact approach we studied before, which is answering these three questions. We start with the first question, which is the number of solenoids. And we said this is straightforward. The number of solenoids correspond to the number of sequences we have. So we have 1, 2, 3, 4 sequences. So we will have 4 solenoids. Straightforward. The second question, which is the more important question, is what about the number of relays? How many relays do we have here? We said that the first motion is always activated by one relay. So we will have one relay here. And then we see this next one, B here. Compared to the previous, B is different than A, so it's 0. So different cylinders means no relay is needed to be added. Now we move to the next one. It's B. Compared to the previous, B and B, they are the same, so I would need a relay here since I cannot perform the sequence for the same cylinder by the same relay. So the same motion cannot be activated by the same relay. Then we jump to the next one. It's A. Compared to the previous one, it's different, so no need to add a relay. So now we have a total of 2 relays. So in this sequence, or to build this sequence, we will have 2 relays. So now the last and most important question is what relays activating which solenoids? And the answer is again simple. A and B, they are different cylinders, so they can be activated by the same relay. We can call it in this case K1. B and B, they are for the same cylinder, so they cannot be activated by the same relay. B and A, they are the same, they are for a different cylinder, so they can be activated by the same relay. So this means that activation of A plus and B plus will happen by K1, activation of B minus and A minus will be done by K2. This means that solenoid Y1 and Y3 will be activated by K1, Y1, Y3 by K1, and B minus, A minus corresponding to Y2 and Y4 will be connected to relay K2, Y2, Y4 connected to relay K2. So now, since we answered all questions, we can move to FluidSIM. So now moving to FluidSIM. I did this pneumatic circuit ready already so that we save some time. The only note is that sometimes I add something called external load, which you will see here as 0 as default, but you can add it as 200. This external load will slow down the cylinder as it moves. This will help us visualize the sequence as we run it. So once we run the sequence, it will help us visualize it since it will be slower. All right. So now let's start with our circuit. How many solenoids do we have? We said we have 4 solenoids. So we get our solenoids. First one, then we have 4. Second one, place it close to each other this way, and we have 4 solenoids. We name the solenoids accordingly. We said this one is Y1, this one as Y2, this one as Y3, and this one as Y4. All right. Then we move to the next question, which is the number of relays. We said we need 2 relays this time. So one relay here and another relay here. So we will need 2 relays. We named this one as K1, K1, and K2. All right, and we said that each one of them will correspond to a switch here that is connected to the solenoid. So each one of them will be corresponding to a switch connected to the solenoid, as you can see here. So we do the connection, we do the connection, we do the connection, we do the connection. We said that A plus B plus, which are Y1, Y3, are connected to K1. So Y1, and Y3 are connected to K1. And we said that B minus, A minus, which are Y2 and Y4, are connected to K2. So Y2, Y4 are connected to K2. Sounds good? Yes. So now we want we said that each solenoid will be activated by a normally open switch and will be deactivated by a normally closed switch. Right? We said every solenoid will be activated by normally open switch, deactivated by a normally closed switch that correspond to the limit switches we can see here. Exactly similar to what we used to do in the pneumatic stuff. All right? So we do the same thing for all solenoids. We do the same thing for all solenoids, and we do connections before we name them. We do the connections, and now it's time to name them. So starting with the first sequence, which is A plus, which is also corresponds to solenoid Y1. So this one. So when do I want A to extend or Y1 to be activated? We have two options. It's either A1, limit switch A1, or limit switch B1, whenever both are retracted. So what should be the answer? What should I choose? The answer is simple. You just need to look at the sequence. So the sequence goes this way, and then it restarts this way, right? So the final sequence before the extension of A was A minus, indicating that this should be activated by A1. So whenever the cylinder A is fully retracted, which was the last sequence, the extension will happen. To ensure that what we said is right, in the previous example, or in the previous tutorial, the example we solved, this was the sequence. So the sequence ended with B minus, and the following one is extension of A, of course. That's why extension of A happened by B1, which is, so that here in the previous tutorial we had this as B1, but since now the last thing is A minus corresponding to limit switch A1, we put A1 as here. And now when do we want to deactivate the extension of A? We want to deactivate the extension of A whenever it's fully extended. So whenever it's fully extended and limit switch A2 is activated, we want to stop the extension. So now we are done with this one. Looks good. What is the next sequence now? The next sequence is B plus. B plus corresponds to what? Corresponds to Y3. So we go here to Y3, this one. And as we said, it corresponds to Y3. So when do I want Y3 or the cylinder B to extend? I want cylinder B to extend whenever cylinder A is fully extended. Whenever cylinder A is fully extended, I want cylinder B to start extending. And when do I want cylinder B to stop extending? Whenever cylinder B itself is fully extended. So whenever cylinder B is fully extended, I want to stop the extension. So now we are done with A plus, B plus. The next one is B minus. B minus corresponding to Y4. B minus again corresponding to Y4. So we are working here. So when do we want B to retract? We want B to retract whenever it's fully extended. The previous sequence, whenever it's fully extended, we want B to start retracting. And when do we want B to stop retracting? Whenever it's fully retracted. Whenever it hits limit switch B1, we want it to stop retracting. So now we are done with A plus, B minus, and we are left with A minus. A minus corresponding to Y2. All right. When do I want A to start retracting? I want A to start retracting whenever B is retracted. How can I know B is retracted? While B hits B1. And when do I want cylinder A to stop retracting? I want cylinder A to stop retracting whenever it's fully retracted. All right. So now I'm done with this sequence. Now we just connected to the power and the ground. And we will have it looking like this. And we have the ground here, which is this one, looking like this. See. All right. So now we are done with almost 80% of the sequence. You can see that we just following an exact same and systematic approach. No need for extensive logic, no need for any extensive understanding. All right, so we have been able to draw 80% of the things, 80% of the circuit with straightforward stuff. Now we come to the relays, which some of you might consider as a bit confusing, but I'll try to simplify it as much as possible. So relays, so in the previous tutorial, we had only one relay. So one relay was connected directly to the power and the ground, since we wanted the relay to keep on working forever. But this time we have two or multiple relays. So whenever one relay is activated, then the previous one will be deactivated, and so on. So we cannot directly connect them to the power supplies. There should be some switches. And the general rule of thumb says that we don't want the two relays to be operating at the same time. What do I mean by that? When K1 is activated, I want K2 to stop activating or to not be activated, and vice versa. Whenever K2 is activated, I want K1 to shut down and do not be activated. How can I do that? We said that we can stop or we can deactivate by the normally closed. So again, we use the normally closed. We call this as K2 and we call this as K1. So this arrangement you will see in most relay examples where we have multiple relays. We don't want the relays to be operating at the same time. So for example, whenever K2 is activated, all right, we want K1 to be deactivated. So this switch will break the circuit of K1 and K1 will be deactivated. And the same thing, whenever K1 is activated, this switch will break the circuit from K2 and K2 will no longer be activated, and so on. All right. So now we come to the part that is way important, and I'll elaborate it and I'll try to make it as easy as possible, and how to activate them. Now we need to activate the relays, of course. Now we studied how to deactivate them, but since we can deactivate them, we need to also activate them. We cannot have just normally closed switches. So what should be these two switches? Of course, they will correspond to the limit switches on top. But which one? So here we get back to this place. Firstly, relay 1, K1, will look like this. So in relay K1, both cylinders will be retracted as shown here. Both cylinders will be retracted. So in order to activate K1, it's either we activate it by A1 or B1. How do I know which one to put? In order to understand which one to add, whether it's A1 or B1, we need to look at the sequence itself. K1 corresponds to both sequences, A plus and B plus. So since A plus happens before B plus, if we add A1 or we make the activation of K1 by A1, whenever the cylinder starts moving this way, A1 is deactivated and K1 is no longer activated. This will result in cylinder B not being able to extend. But if we activate K1, by B1, this will ensure that, okay, B1 is static, it doesn't move, it allows A plus to happen, it allows B plus to happen, and then K1 is deactivated. So what is the right thing to add? It's B1, the one that maintains the position until K1 is deactivated. Which cylinder I needed to maintain the position? I need cylinder B to maintain the position, not cylinder A. Cylinder A, because cylinder A will initially extend before cylinder B. So the one that maintains position is cylinder B. Therefore, the limit switch here will be activated by B1. All right. Now let's talk about K2. So when we reach before activating K2, this is what will be happening. Both cylinders will be extended, right? Both cylinders will be extended. So it's either A2 or B2. How to know whether I put A2 or B2? We said we want the cylinder that will keep on waiting until the other one operates. So the sequence is B minus and then A minus. So we want cylinder A to keep on waiting until B retracts and then it retracts. So since cylinder A will be waiting, so it will be on A2 the whole time K2 is activated. So here we will just say A2, because cylinder A will wait. In the other way around, in the K1, cylinder B had to wait before it extends. But here, cylinder A had to wait before it retracts. So this way, you can build the logic. If we connect this way, now everything should be right. We do this, the run, A plus, B minus, A minus, and it latches again and again and again. So as you can see, A plus, B minus, A minus. So what I'll consider straightforward and easy to grasp from all of you, I think that no one of you should have any confusion about this part, because it's straightforward, easy to do. This part, for some of you, might be confusing, but I believe that if you repeat the video again and try to understand it perfectly and implement it, you will never forget it, and you will be able to, even if you have another examples where these examples are a bit challenging, they are not they are more complicated than this, you will need to add switches and so on. At least if you follow this systematic way, you will always approach 70% or 80% of the solution. So at least you have something to start from. And whenever you run the sequence and it's not running well, it's fine. Just click on this and see the sequence one by one. See what extends, what line is activated while it shouldn't be activated, and what line is not activated while it should be activated. So like it's a kind of a debugging stage. All right. I hope you understood this tutorial. I hope it was straightforward, easy, and I believe it was straightforward, easy. As I keep on saying, practice a lot. Good luck in your exams. Good luck in your course, and see you in the next tutorial.